Hello and welcome everyone to the Coding CEO channel. Today we will see the concept of object-oriented programming, that is OOPS concept using Python. In the OOPS concept, we have basically the five main pillars or five main columns. First one is classes and objects. Second one is inheritance. Third one is polymorphism. Fourth one is encapsulation. And the last one is abstraction. So talking about the classes, it is a blueprint of an object. Okay. What is object? It is a physical entity which is an instance of class. Okay. So class is a logical entity that has some specific attributes and methods. And objects can perform operations related to the classes. So clear with classes and objects? So in Python, which supports object-oriented programming, the concepts like classes, object, inheritance, polymorphism, and encapsulation, they are existed. Talking about the inheritance, in the Python, inheritance is used to create a new class, that is modified version of an existing class. Okay, the new class can inherit the properties and methods from the existing classes. This is called the inheritancy. Okay, we have seen the parent child concepts in the inheritance concept. Okay, talking about the polymorphism. Okay, so many forms, it means many forms. So basically polymorphism refers to the ability of an object to take on many forms. In Python, polymorphism is achieved through method overloading and method overriding. Okay, encapsulation. So it is a process of hiding the data and methods within a class, so they cannot be accessed directly from outside the class. Okay, we have seen the last concept of abstraction. It is the process of hiding complex implementation details and showing only the essential features of the object. Okay, so basically in Python, we can the abstraction can be achieved through abstract class and interfaces. Okay, we have talked about the polymorphism about method overloading and method overriding, right? So what is that? The method overriding, it is a process of redefining a method in a subclass. Okay, so that is already defined in its parent class. Okay, talking about method overloading, it is a process of defining two or more methods with the same name in a class with different parameters. Now I will talk about the self keyword. Okay, so it is a special keyword in the Python which is used to create an instance of a class. Okay, talking about the init, it is a special method. Okay, so init is a method, self is a keyword. In Python, init is a method in Python which is used to initialize the instance of the class. Okay, so we will see in the examples. Just clear it out. Okay, now we will see the basic example of OOPS concepts. Okay, like class and objects. Okay, so we can define a class. Okay, so class, sorry, my bad, it is always a small case. Animal. Oh, okay, so it has a def underscore underscore in itself, comma name, comma age, but I don't require the age now. Okay, now for take make def make underscore sound. Okay, okay, now I have defined a subclass. Okay, and define a subclass. Okay, that is class dog animal. Okay, so it has also a self and comma name, and using the super method it is defining the name. And when we call the make underscore sound method, it will print this is set.name sound, the sound of the dog. Okay, We can make another class, okay, another subclass that also inherits from animal. Okay, so class cat, which is also the animal, and it is also the same. Okay, so now let's create objects from the classes. Okay, let's create objects from both of the classes. Okay, that is my underscore dog and my underscore cat. Now we need to call the methods on that particular objects, right? Right. So just see this. And for our safety or understanding, I have right here animal. Okay. So whenever it prints this animal and this is and the other text, so we know that it is print. Oh, sorry. Not here. Just my bad. I want to print this here. Okay. So we will know that it is make underscore sound. It is a method from animal class. Okay. Not from dog or not from cat. Okay. So whenever it prints, just run this. Okay. Here we go. Okay. So basically in this example, okay, just see the example. So basically in this example, we define a class called animal that has an init method, okay, which is called when an object of the class is created, okay, and a make underscore sound method which is left undefined, or we can just print simple messages. Okay, here we then define two subclasses of animal called dog and cat, which each defines their own implementation of make underscore sound method. So we then create objects from these classes, that is my underscore dog and my underscore cat here. Okay, and at the last we call the make underscore sound method on each object to demonstrate the polymorphism. Here the concepts of the polymorphism happen. Okay, so make underscore sound, it is polymorphism, it has many forms. Make underscore sound, it has a many forms. Okay, got it. We can create a new variable my animal, my underscore animal equal to animal. Okay, and pass the name as animal in it. We also can call my animal, my underscore animal dot make sound. Just run this, what it prints, the animal. This is animal sound. Got it. So now we will know that how the polymorphism will work. Okay, so just talk about the just now talk about method over riding and method over loading. Okay, so we will see the classes animal, dog and cat only. Okay, but with some little changes. Okay, so I will just copy paste the code. You need to just read it out or just see this. So I have one class animal which prints something. I have one class called dog which inherits animal and which also has a make underscore sound itself, a method itself defined. Okay. We also have a similar cat which is also have the def make underscore sound method. Okay. Now what is method overriding? We will see that. Okay. And for that we have this method overriding example. What I defined you about method overriding, I will repeat it. Method overriding is the process of redefining a method in a subclass that is already defined in its parent class. Okay. So actually make underscore sound is defined in dog. This method is defined in dog, but make underscore sound is already predefined in its parent class of dog, which is animal class. In the animal class we already have make underscore sound. So this is the method overriding. It is overriding the methods. Okay, and the outputs are already shared in the comments, but I will run it. Okay, the animal makes a sound, the dog barks, and cat meows. Okay, just now. Now for the next. Okay, for the next, we need to create one new class for the method overloading example. This is what we have done, method overriding example. Okay, but method overloading example, we need to have this class. Okay, the same method is present in one class itself. Okay, this is the method overloading example. So we have defined a math object for math operations class, and we when we pass two arguments in add, it will itself call this method. Okay, and return the output a plus b. Okay, by 2 plus 3 equal to 5. And when we pass three arguments in add, it automatically refer to this method. Okay, and returns a plus b plus c, that is 2 plus 3 plus 4, which is 9. This is method overloading. It is overload something. Okay, it is predefined. Okay, so when to call this add first add method, or when to call the second add method, it is defined by the number of arguments. Okay, so basically in the given two codes we have seen previously, we have seen the concepts of method overriding and method overloading. Okay, so the method, for talking about the method overriding, we have seen the animal class, which defines a method called make underscore sound, which prints a generic sound. The dog class and the cat class both inherit from the animal class and override the make underscore sound method with their specific sound. Okay, so when we create an instance of animal, it calls the make underscore sound method defined in the animal class, and it prints basically the animal makes a sound. When we create an instances of dog and cat, they call their respective make underscore sound methods. Okay, and they print the dog barks and the cat meows respectively. Talking about the second method overloading, the math operations, the class we define two methods called add. Okay, but with different parameter lists. The first add method takes the two parameters a and b and return there some a plus b, right? But in the second add method, it takes the three parameter a comma b comma c and it returns there some a plus b plus c. Now in Python, method overloading is not directly supported. So second add method in the math operation class replaces the first add method. Okay, when we create an instance of math operations and call the add method with two arguments, it performs the addition with the two numbers and return the result. When we call the add method with the three arguments, it basically performs the addition with the three numbers and returns the result. Overall, this example demonstrates the concepts of method overriding and method overloading in Python, showcasing how methods can be redefined and defined with different parameters in subclasses and classes respectively. Talking about the next concept, we have concepts called classes and objects. Okay, so till date we have seen the inheritance, polymorphism, and the two types of the polymorphs, right? But now we have seen the pure classes. Okay, so just need to define a class. Just we need to simple define the class car. It has a init method make model year. Make dot self dot make equal to make self dot model equal to model, and same for year. The description we have to print them all. Okay. Now we can create an object from that class. right? And we can simply call a method on that object. Okay. Now why we use print here? Because it returns, right? So whatever the output it return, it gives here, and basically we call the print that output. Okay, that's why we need a print. Okay, when we run it, it gives us year, name, and model, right? Oh, sorry, make. Who is maker, right? Now we have seen the inheritance, right? In Python, inheritance is used to create a new class, that is a modified version of an existing class. Okay, so we will see that using this car only. We just delete this, remove this, and define a subclass that inherits from car. Okay, so we have electric car. It has make, model here, but it has an advanced feature of battery size. Okay, and we have printed make, model, and this one. Okay. We can add a year also here. No worries for that. But we need to create a class. Hey, we need to create an object from a subclass. What is that subclass? My underscore electric car. Okay, this is the object, and this is the subclass electric car from a inherited class called car. Okay, now we can print, or we can basically call the methods on that objects and see what the output we get. Okay, just save it, run it, and here we go. 2022 Tesla Model S. The Tesla Model S has 100 kilowatt battery. When we call the description, it will print the year, make, and model. When we call the battery life, it will print this message, right? So this is called as inheritance. Basically, to create a new class that is a modified version of an existing class. So car is an existing class and electric car is a modified version of it because it has battery life. Okay, battery size. We can just remove this and learn a new concept called as somewhat encapsulation. Basically, encapsulation is the process of hiding data and methods within a class so they cannot be accessed directly from outside the class. Okay, so I just write a definition here and then print it. Okay, yeah, we will cover the abstraction also. Copilot, suggest me do it. So we need to have a class called bank account. Okay, we have here a private variable. What is that private variable? In the oops concept, we have one another concept, that is access modifier. Okay, so Python basically does not support access modifiers directly. What are the access modifiers? The private, the protected, the public. Okay, we can see in the different languages we have these keywords to define the access modifiers, but Python does not support access modifiers directly. However, we can use the conventions like underscore and underscore underscore. Here we have used self dot underscore underscore. So that means this underscore underscore and after that balance, this variable is the private variable we have defined. Okay, now we have a deposit, withdraw, and get balance functions or methods, whatever you need to call. The same with banking operations, right? So what is encapsulation? It is a process of hiding the data or methods within a class so they cannot be accessed directly outside the class. Okay, so we this is the definition, and by this definition we will mean that we cannot access this balance variable because it is a private variable, right? Directly outside the class. What do you mean by outside? We cannot basically, let's create an object from the class first. Okay, so here is the, okay, now try to access the private variable directly from outside the class. Okay, what it gives, it gives you the error. Okay, bank account object has no attribute underscore underscore balance. So we cannot access the private variable directly. Okay, it will raise an error. So we can use the access private, we can access the private variable using a getter method. Let's see how we can do that. Okay, we have our val 1000, right? So we are able to access it. Now we can try to modify the private variable directly. Let's see what happens. And just print my underscore account dot get balance. Okay, okay. 1000 and 1000, we cannot directly modify it. Okay, it will not be allowed, but it also not thrown any error, right? Now just we need to try to modify the private variable using a setter method. Okay, we try to access the private variable using getter method and try to modify the private variable using setter method, right? Now we need to print my underscore account dot get balance. It is modified, right? It is modified by 500, right? It deposit, right? So we need to try to withdraw more than the available balance. Okay, obviously it will not be allowed, right? So it may give you error insufficient funds, right? Because we have written here a else statement. Okay, now we can withdraw valid amount, right? So we can withdraw it and try to check it. Okay, try to check the balance again. We have withdraw 500 and the remaining balance is 1000, right? So we have get a successful encapsulation code. So basically this code demonstrates how encapsulation works in Python by defining a class with private variable, that is underscore underscore balance, and the methods that can modify and access this variable. The private variable basically cannot be accessed directly from outside the class, but can be accessed using getter and setter method, right? So now we just need to have a discussion remaining about abstraction. So what is abstraction? Basically, abstraction is a process of hiding complex implementation details and showing only the essential features of the object, right? We have that animal, dog and cat again, but here with a different syntax. From ABC, we have to import ABC abstract method at the rate abstract method. This is the decorator. Okay. Class dog, class cat, and their sounds. Right? Just now we can create objects from the classes dog and cat. That is my underscore dog and my underscore cat. Now we can call the sound methods on that objects, right? Meow and woof. But what is the difference in this? What is the use of abstraction? Basically, this code demonstrates how the abstraction works in Python by defining an abstract base class animal with an abstract method sound and two concrete subclasses, that is dog and cat, that implement this method in different ways. The abstract base class and method define the essential features of an animal, while the concrete subclasses provide specific implementations for different types of animals. In the main part of the code, we create objects from concrete subclasses, right? And call the sound method on them. Without needing to know the implementation details of each animal, this is an example of abstraction. So where we can hide the complex implementation details of the sound method, and basically show only the essential features of producing a sound. So we have this only, okay? So basically, object-oriented programming, in the conclusion, it is an important paradigm in Python and programming in general. It allows us to organize our code into reusable and scalable units, and which enables us to write more maintainable and efficient code. Basically, it is a programming paradigm that focuses on creating objects that contain both data and behaviors. Classes are used to define the structure of the object, which can then be instantiated as individual instances. Okay, encapsulation, which refers to a practice of hiding element implementations details, okay, and exposing only necessary information through well-defined interfaces. Abstraction is a process of modeling complex systems by focusing only on relevant aspects. Inheritance, it allows classes to inherit the properties and methods of the other classes. So from other classes, it inherits, right? Which promoting the code of reusability and modularity. Polymorphism, the main concept, it allows objects to be used interchangeable regardless of their specific class by implementing methods with the same name but different functionality. By understanding this core concept, OOPS developer can create a more efficient, modular, and maintainable code. So I hope this video has helped you to understand the basics of the OOPS in Python or in any other programming languages. Thank you for watching this video, and till then, happy coding.